So good morning all. Welcome you back to the lecture series of electrical wiring and safety. So we are discussing about the load calculation today in this session. So before moving on to load calculation, we have to know about some key terminologies which is very helpful to understand the load calculation properly. So this particular unit is under the course electric circuit and electron devices for the first year computer science and design engineering. Hello everyone, this is Jagdish, Department of Biomedical Engineering and an assistant professor, helping you to know how to calculate the load properly. So now let's move on to the topic. So how the electrical loads are classified initially. So this is the broad classification what you see on the screen. So we have three classifications. The first one is resistive load, second is capacitive load, third is inductive load. So we have broad classifications. So since it is a basic fundamental course, we need not to move in depth into the resistive, capacitive and inductive load. Just we have to understand what these terminologies are and why it is different from one another. So resistive load is just directly taking the energy or the power source and converting into another kind of energy. For example, take the iron box or take any kind of light which is functioning with the help of power and converting the power into one more type of energy which is in the form of light or in the form of heat. So this kind of load or the consumption of power is called resistive load. And second is capacitive load. As you see here, the word capacitive load itself insists that it will include a capacitor to draw the power from the source and to utilize it further. So when we talk about capacitor, it is a kind of temporary storage device where the power is being consumed by the capacitor and it is stored for a certain duration of time and it will be delivered after a short duration of time when required. So this is how when the power or energy is being stored and reused, that kind of load is called capacitive load. And let's move on to the last classification here, that is inductive load. So as you see the diagram over there, it consists of an inductor, a motor and a transformer. When you see all these components, we have to remember about the Fleming's left hand thumb rule. So where it involves the principle of magnetic field in the operation of either a motor or a transformer. So for example, the working of a motor involves the principle of Fleming's left hand thumb rule, where a coil is being rotated in a magnetic field to produce a mechanical force or energy. When the power is being utilized for this kind of load, we call that as an inductive load. So we have broadly three classification: resistive load, capacitive load and inductive load. So this is the basic classification of electrical loads. Now let's move on to few more details on the load. That is, we have to know about the key terminologies in order to calculate properly the answer for the given cases or the problems. So here the first kind of load is called connected load. So I have given a brief note on what is meant by connected load. So it refers to the sum of the rated capacities of all electrical devices expected to be connected to the system. So I have also given the picture in this slide for your better understanding. So here we have a air conditioner, we have a washing machine, we have a light, all has been mentioned with their power consumption unit in terms of watt. So it has been connected to the main supply and these loads are not active. So when in that case we call that as a connected load. We have simply connected that to the system and it is not active or which is not in live or in use. So when it is just simply connected without operating or consuming the power, we call that load as connected load. I repeat the sentence once again for you. Connected load refers to the sum of all the rated capacities of all electrical devices expected to be connected to the system. And let's move on to the second load, which is called demand load, so which is termed as the load accounts for actual usage, considering that not all connected device will operate simultaneously. Suppose you see the diagram demand load. So in the equipments which is seen on the diagram, for example, if we have 4 or 5 equipments, all the 5 or 6 equipments are not active on the same time. Only few will be active or only few will be working according to our need. Such kind of load is called demand load. For example, if you have air conditioner, a washer, a light and TV unit in the demanding load, if you are using air conditioner and television which is directly connected or consuming the power, and such kind of load is called demand load, so which demands power for their operation. Even though the others are connected, they are classified as connected load but not demand load since they are not operating. So in this class we have broadly classified what is electrical load, that is resistive load, capacitive load and inductive load. These are the broad classification of electrical load. For the sub-classification or subcategories of loads are connected load and demand load, and that has been discussed in this particular video. So further we will move on to how electrical wiring diagrams and installation plans will be done in our next session. Thank you all for watching.